So hello, today is the fifth problem solving session for the course Environmental Chemistry and Microbiology. The course instructors are Professor Anjali Pal and Professor Sudha Goel, and I am Shrija Ghosh, a PMRF at IIT Kanpur. I am here to solve all the doubts related to your assignment that is given for the fifth week session. Today's week is about chlorination, and we have different nitrogen nitrogenous compounds and their uh, different types of reactions. So we will talk about denitrification, nitrification, ammonification, and different terms. Okay. So we have different questions related to these topics, and we'll be uh, discussing it one by one. So I'll just turn off my camera to save the bandwidth. Starting with the first question, the full form of THM is. What is the full form of THM? Option A, trihydroxymethane. Option B, tetrahalomethane. Option C, trihalomethane. And option D, tetrahydroxymethane. What is the full form of THM? So, if anyone who knows the answer, please write it in the chat box. Even if you don't know the answer, just try to guess it and write it in the chat box, both of you. What do you think THM could be? Trihydroxymethane, tetrahalomethane, trihalomethane, or tetrahydroxymethane? Okay. Smita says option A, trihydroxymethane. Okay. Anyone else? The correct answer is trihalomethane. So these are like when we do chlorination, uh, lot of times we get these compounds as the product trihalomethane. So basically there are three halogen molecules attached to the methane molecule. So methane is basically CH4. So this is methane. And when three of the hydrogens are replaced by halogen molecules, so halogen means chlorine, bromine, fluorine, all these molecules are halogen molecules. Okay. So all these molecules are halogen molecules. So any halogen out of fluorine, chlorine, bromine, iodine. So all these molecules, any of these molecules are when they replace the hydrogen in the methane, they will be known as trihalomethane. Okay, because there are three halogens, so trihalomethane. Moving on to the next question. At what pH chlorine in water acts as a hypochlorite only? Option A less than 5, option B greater than 5, option C greater than 10, and option D greater than 3. At what pH chlorine will act as hypochlorite in water? Anybody knows the answer? If you know the answer, try to answer it in the chat box. Or just guess it. At what pH chlorine in water acts as a hypochlorite only? So the answer is greater than 10. So this is the graph that shows the relative amounts of HOCl, that is hypochlorite, and OCl minus, that is the hypochlorite ion. So if you see, the HOCl percentage is decreasing with pH, and OCl minus ion is increasing in percentage. Okay, this axis is written in opposite, so this is 0 and this is 100. So slowly from so whenever we do chlorination, so what chlorination means, we dissolve the chlorine in water, and as a result we uh, form these hypochlorite uh, uh, hypochlorites. So when this molecule forms, it kind of gets dissociated into its respective ions. So this ionic form is predominantly present after pH 10. So before pH, uh, so below pH 5, 100% of HOCl will be there, and above pH 10, 100% of OCl minus will be there. Okay. So the relative amounts of HOCl and OCl minus depends on pH. Okay. If the pH of the solution is less than 5, then HOCl will be there predominantly. And if the pH of the solution is more than 10, then OCl minus will be there. Okay. So correct answer is more than 10. This is clear to everyone? This graph is clear to everyone, right? So the percentage of HOCl and OCl minus is relative and it depends on pH. So the pH at which HOCl is almost 100% is pH lower than 5, and the pH at which OCl minus, that is the hypochlorite ion, that is present in 100% is the pH above 10. Okay. I hope that's clear. Moving on to the next question now. Question number 3. During chlorination, with the rise in temperature of water, the death rate of bacteria, option A, increases, option B, decreases, option C, remains unaffected, and option D, none of the above. During chlorination, with the rise in temperature of water, the death rate of bacteria, option A, increases, option B, decreases, option C, remains unaffected, and option D, none of the above. What do you think happens here? What do you think after chlorination or during chlorination? What will happen to the death rate of bacteria? Will the bacteria die, or will the death rate of bacteria decrease? So do you know why chlorination is done? What why do we do chlorination of water? So chlorination is basically done to disinfect the water. Okay. So now what do you think? If I'm telling you that chlorination is done to disinfect the water, then what do you think the death rate of bacteria is going to increase, decrease, remain unaffected, or none of the above? Okay. Deepika is saying A and Ipsmita is saying B. The correct answer is actually A. So I told you that chlorination is done to disinfect. What do you mean by disinfection? So if you ever get a cut somewhere on your hand, on your leg, then what do? You put some amount of Dettol or Savlon, right? So those are called disinfectants. And why do we add those things to our wounds? So that we can stop the bacteria or stop the infectious agents to grow there. Okay. So if I get a cut, I'll put Dettol as a disinfectant to stop the growth of bacteria. Similarly, all our drinking water, they are chlorinated to disinfect the water so that it is fit for us to drink it. Okay. So basically by chlorination, we are killing the bacteria in them, the disease causing microbes in them, so that they can be consumed. They are fit to be consumed by humans. Okay. So that when we are drinking the water, we are not going to get any kind of infection or any kind of disease. Okay. So basically we are killing the bacteria by doing chlorination. So during chlorination, the death rate of bacteria is increasing. That's clear? So chlorination is a process of adding chlorine or chlorine compounds such as sodium hypochlorite or calcium hypochlorite to water to disinfect it, making it safe for drinking, swimming, and industrial use. This method effectively kills bacteria, virus, and other harmful microorganisms. Okay, I hope that's clear, Ipsmita. So moving on to the next question. Question number 4. Normal dose of chlorine during post-chlorination is. Now, normal dose of chlorine during post-chlorination. What should be the normal dose of chlorine post-chlorination? During post-chlorination should be. So, option A is 0.5 to 2 ppm. ppm means parts per million. Okay. So, option A is 0.5 to 2 ppm. Option B 0.1 to 0.2 ppm. Option C 0.8 to 1.5 ppm, and option D 1 to 5 ppm. What should be the normal dose of chlorine during post-chlorination? Any idea? Deepika says it's B, 0.1 to 0.2 ppm. Okay. Anyone else wants to answer? Or should I go with this answer? So the correct answer is option B. So Deepika is right. 0.1 to 0.2 ppm, that is the normal dose of chlorine during post-chlorination. So post-chlorination, and so there are two terms, pre-chlorination and post-chlorination. It basically means whether you are doing the chlorination before filtration or whether you are doing the chlorination after filtration or water treatment. So whenever we have a like the source of the initial source of water is your water bodies, right? So whenever you are getting the water from any water body, it goes through certain water treatment. Okay, you must have heard about sewage water treatment plants. So there are different kinds of water treatment plants, and they have different steps in during the treatment of water. So the water first goes through physical filtration, then it goes to some other steps. So before water treatment, if we do the chlorination first and then treat the water, like then filter the water and do other things to it to make it fit for drinking, that will be called pre-chlorination. Okay, and if I take the water from the water body, let's say I'm getting the water from river, treating it, doing the whole water treatment, filtration and everything, and then doing the chlorination, so that will be called post chlorination. Okay, so during post chlorination, the dose of chlorine that is used is 0.1 to 0.2 ppm. For pre chlorination, I think you will require a higher amount of chlorine. Can you tell me why? What do you think will happen during pre chlorination? Will we require higher amount of chlorine, and if yes, why? Anybody? Just think logically. If I'm not treating the water and I'm adding chlorine first, that means the water will have higher amount of uh, The water will have higher amount of organic matter in it, and that's why you will need higher amount of chlorine to treat the water, like to do the proper chlorination of the water. Okay, if I'm treating the water first with other methods and then doing the chlorination, then we'll require 0.1 to 0.2 ppm of water, chlorine for the chlorination. That process is post chlorination. Okay, I hope that's clear to everybody. Only one person answered this question, so I'm assuming others have understood because she has answered it correctly. So I hope everybody is understanding. Okay. Moving on to the next question now. Next question is question number 5. Hypochlorous acid dissociates through the following reaction. HOCl goes to H plus OCl minus. Okay. Hypochlorous acid, this is dissociating into the proton and the hypochlorite ion. And the dissociation constant Ka is given as 2.7 into 10 raised to the power of minus 8 at 20 degrees Celsius. Calculate the ratio of OCl minus divided by HOCl concentration present at a solution pH of 2. So you have the reaction given. This is very similar to something that we have already discussed in the first session. Okay, so think logically. We have the reaction given, hypochlorous acid dissociating into H plus and OCl minus. Okay, its respective cation and anion. The dissociation constant is given. We have to calculate the ratio of concentrations of OCl minus by HOCl, and pH is given as 2. How do we calculate it? Anybody? Try calculating it. I'm giving you time. Try to calculate it and tell me what answer are you getting. It's not very difficult. Everybody try it. I can do this calculation without use of any calculator. It's that easy. Think clearly. I have already told you how to solve these type of questions in the first session, and this is very similar to that. Okay, Deepika has calculated it. She's saying B. Anybody else? What about others? Solve it fast. So others are not able to solve it. I'll assume that, or they are not paying attention to the class. Either or. So whatever it is, option B is the correct answer. So basically we have the pH given. So I told you what is pH. pH is minus log of H plus ion concentration, right? So if I have the pH given as 2, this will be equal to minus log of H plus ion concentration. And from here you can calculate the H plus ion concentration to be 10 raised to the power of minus 2, right? Now what is given? We have the dissociation constant. Now how do we write the dissociation constant for any reaction? The concentrations of the products divided by the concentration of the reactant. So dissociation constant for this reaction will be concentration of H plus multiplied by concentration of OCl minus divided by the concentration of HOCl, hypochlorous acid. Okay, and this is already given as 2.7 into 10 raised to the power of minus 8. Now, what is the H plus ion concentration? H plus ion concentration is 10 raised to the power minus 2. That means this will get divided by 10 raised to the power minus 2 and we will get the answer what we have to find. We have to find OCl minus concentration divided by HOCl concentration. So we will get the desired ratio by just dividing the Ka by 10 raised to the power of minus 2. And if I divide 10 raised to the power minus 2, that means the answer will be 2.7 into 10 raised to the power of minus 6. This is clear? Is it clear now? Ipsmita, you have written not able. So are you understanding the solution now? I have written the clear solution here. Let me know if you don't understand this. I can explain it again. Okay, great. Others also have understood the solution, I hope. 2 of you have already written option B, so I'm assuming you got the answer correct. And this is how you must have solved it as well. So basically, whenever the dissociation constant of any reaction is given, just write it in its formula. So dissociation constant will be equal to the concentration of product divided by the concentrations of reactants, and then just solve whatever is asked in the question. Depending on that, just calculate. Whenever pH is given, you can always calculate the H plus ion concentration. If H plus ion concentration is given, you can always calculate the pH of that. Okay, simple. Now we'll move on to the next question. Question number 6. Chlorine demand of water is equal to option A, applied chlorine, option B, residual chlorine, option C, sum of applied and residual chlorine, and option D, difference of applied and residual chlorine. Chlorine demand of water is equal to what? Option A, applied chlorine, option B, residual chlorine, option C, sum of applied and residual chlorine, or option D, difference of applied and residual chlorine. What is chlorine demand? Anybody? No one? What is chlorine demand? Option A, applied chlorine, option B, residual chlorine, option B, sum of applied and residual chlorine, and option D, difference of applied and residual chlorine. Just take a guess. If you don't know the answer, just take a guess. Think logically, what could it be? The correct answer is option D, difference of applied and residual chlorine. So chlorine demand is the amount of chlorine required to react with the impurities such as bacteria, organic matter, ammonia, metals, whatever it is, in water before a free residual chlorine level is achieved. It represents the difference between the chlorine added, total chlorine added, and the residual chlorine remaining after a set contact time. Okay. So basically it is the chlorine dose that is given to the water, and once I have so let's say I have added 2 mg per liter of chlorine, okay, to the water, and after the after the chlorine has completely reacted with all the impurities, that is bacteria, organic matter, ammonia, whatever is there in the water, it has reacted with everything, and now the remaining chlorine that is there. So let's say after reacting with everything, 0.5 mg per liter chlorine is still there. Okay. So that would be the residual chlorine. So I started with 2 mg per liter and 0.5 mg per liter is remaining. That means the chlorine demand is 1.5 mg per liter. That the water required that amount of chlorine to kill all the impurities, that whatever is present in the water. That is clear to everybody. What is chlorine demand? Is that clear to everybody? What is chlorine demand? Chlorine demand means the amount of chlorine required to react with all the impurities. So basically whatever I'm adding and whatever is remaining after all the reaction that has happened. So if you subtract that, whatever is the difference, that is the exact amount of chlorine that was required by the water for all the impurities in the water to react. Okay, and there are certain factors that affect these chlorine demand, the amount. First is organic matter and microorganisms. Obviously, I told you that it is the amount of chlorine that is reacting with the impurities. So what are these impurities? Impurities are organic matter and different types of microorganisms. So if we have higher amount of organic content, or if we have higher number of microorganisms in the water, it will have a higher chlorine demand. We'll have to add more and more chlorine for completely removing or for complete reaction with the impurities. Okay. So organic matter and microorganisms, if they are higher in content, they will increase the chlorine demand. Then again, ammonia and nitrogen compounds, they are also going to react with the chlorine to form the chloroamines. And if they are also higher in amount, they will increase the chlorine demand. Also, it depends on pH levels. Why does it depend on pH level? Because I told you the amount of hypochlorite ion in water depends on pH. Okay, so higher pH more than 8 reduces the effectiveness of chlorine, increasing the demand. Why? Because at higher pH, the chlorine will primarily be in the form of hypochlorite ion, but we want it in the form of hypochlorous acid. Okay. So if the pH is very high, then the chlorine will not be very effective, and thus we will require more and more chlorine. So that means at higher pH, more than 8 around, the chlorine demand will increase. Okay. So chlorine demand is dependent on pH levels. It is also dependent on temperatures, because higher temperatures increases the reaction rates and it will increase the demand. Okay. And also the contact time. So longer contact time allows more reaction. So it will decrease the chlorine demand. That's clear. So there are certain factors that affect the chlorine demand. And what is chlorine demand? I hope both the terms are clear now. Moving on to the next question, question number 7. Oxidation of ammonia into nitrites is performed by option A, Nitrobacter, option B, Nitrosomonas, option C, E. coli, and option D, Rhizobium. Oxidation of ammonia into nitrites is performed by Nitrobacter, Nitrosomonas, E. coli, and Rhizobium. Whoever knows the answer can write it in the chat box. Okay, we have two answers. Option B. Both of them are saying option B. Anybody else wants to answer? Oxidation of ammonia into nitrites is performed by Nitrobacter, Nitrosomonas, E. coli, and Rhizobium. No one wants to answer? Okay, both of you who have answered option B, you are right. So the correct answer is Nitrosomonas. So Nitrosomonas is the group of bacteria that can do nitrification. So this is the process of oxidation of ammonia to get converted into nitrite and then later into nitrate. That is called nitrification. Okay. There are certain other terms. We'll go through that also. And the other bacteria that we can see, Nitrobacter and Rhizobium. So they also have different functions. So bacteria responsible for converting ammonia to nitrate are known as ammonia oxidizing bacteria. And the process is called nitrification, as I have already mentioned. And these bacteria oxidizes ammonia or ammonium ion into nitrite using oxygen in the following reaction that is given here. We have ammonia, we have the oxygen, that would be an atmospheric oxygen, and this will get converted into nitrite ions, that is NO2 minus. And this process is called nitrification, and Nitrosomonas is the most common example that can do nitrification. The other options that were there, Nitrobacter, they convert these nitrites further into nitrate. So further oxidation of nitrite will lead to nitrate formation. What is nitrate? Nitrate is NO3 minus. So this NO2 will further get converted into NO3 minus. Okay. So this is called nitrate. Okay. And there was another option called Rhizobium. Rhizobium fixes nitrogen to ammonia. So this is opposite process. So it will do nitrogen fixation. So whatever nitrogen will be there, atmospheric nitrogen present, Rhizobium is generally present in soil. Okay. It is generally present in soil, and whatever nitrogen, atmospheric nitrogen is present in the soil, it will fix the nitrogen. Basically, it will incorporate the nitrogen into other nitrogen containing compounds. It will convert the nitrogen into ammonia. Okay. So that is nitrogen fixation, and it is done by these rhizobium. These rhizobiums are generally present in the roots of leguminous plants, and they are present in the soil. The roots are present in the soil, obviously, and they fix the nitrogen, the atmospheric nitrogen, into ammonia. Okay. So this is how the nitrogen cycle goes on. You must have studied it in school also. These nitrogens are fixed by these kind of bacteria into ammonia, and then later the ammonia is uh, converted into nitrites and nitrates. So ammonia is converted into nitrites and nitrates, and then nitrate is then again converted back to nitrogen. So this ammonia to nitrite is called nitrification. It is done by Nitrosomonas. It is done by Nitrosomonas. Nitrite to nitrate is done by Nitrobacter. Okay, and nitrate to nitrogen, this is called denitrification. And then we have again nitrogen fixation. So this is called nitrogen fixation. This process is called nitrogen fixation. This process is called nitrification. Okay, this process is called denitrification. Okay, this is called denitrification and this is called nitrogen fixation. So this is how a nitrogen cycle goes. Okay, moving on to the next question, question number 8. In fresh bleaching powder, the chlorine content is about what? Option A 2 to 15%, option B 10 to 20%, option C 30 to 35%, and option D 45 to 55%. What is the chlorine content in the fresh bleaching powder? 2 to 15%, 10 to 20%, 30 to 35%, and 45 to 55%. You can answer in the chat box. Okay, Deepika says option C, 30 to 35%. Anybody else wants to answer? Come on, everybody, try to answer. Okay, the correct answer is option C. So you are correct, Deepika. The amount of chlorine in fresh bleaching powder is 30 to 35%. Okay. So bleaching powder is basically calcium hypochlorite. So calcium hypochlorite, that is bleaching powder, it is widely used disinfectant and a bleaching agent. I'm pretty sure you all must be familiar with bleaching powder at home, right? So bleaching powder is generally used in uh, when you're cleaning your sinks and all. You must be at, like, a lot of people use bleaching powder to clean the sinks, wash that we have in wash basins and all. Okay, and then uh, it is also used as a disinfectant in other areas, and it is used to do bleaching, color bleaching also, right? So bleaching powder, it is a very common household chemical. So chemically it is calcium hypochlorite, and it has the available chlorine content between 30 to 35% by weight. And if you have seen the bleaching powder getting dissolved in water, or if you have ever come across a solution of bleaching powder, you must remember a distinct smell of bleaching powder. And you must have seen that it kind of gets hot. The solution kind of gets hot when the bleaching powder gets dissolved. That is because these reactions happen uh, in the solution. So whenever we dissolve the bleaching powder in water, it forms calcium hydroxide and chlorine gas, and that chlorine gas further reacts with water to form hypochlorous acid. And hypochlorous acid is the one that is responsible for all the disinfection that bleaching powder does. Okay, and the color bleaching is basically due to oxidation. Okay, so all the disinfection and oxidation that is happening when we add the bleaching powder to any surface for when we add the solution of bleaching powder to any surface, whatever disinfection is happening, that is happening due to the formation of hypochlorous acid. And that is why the solution is hot, because all these reactions release some amount of heat. Okay, so bleaching powder, chemically it is CaOCl whole twice. It is a widely used disinfectant, you must be familiar. The chlorine content is 30 to 35% by weight, and when dissolved in water, it forms calcium hydroxide and chlorine, and then that chlorine further reacts with water to form hypochlorous acid. So basically, when dissolved in water, it releases hypochlorous acid, which is the active disinfectant. Okay, I hope that's clear to everybody. How bleaching powder is doing the disinfection and what is the chlorine content in the bleaching powder. Clear, everybody? Okay. Then we'll move on to the next question, question number 9. What is the oxidation state of nitrogen in glycine? What is the oxidation state of nitrogen in glycine? And in bracket, you have the formula of glycine. All of you calculate the oxidation state of nitrogen. Write the answers in the chat box. Option A is +3, option B +1, option C -3, and option D -5. Okay. So what is the oxidation state of nitrogen in glycine? Anybody who knows the answer? Write it in the chat box. Deepika says -3. Anyone else? Nobody wants to answer? On others don't know the answer. Any of the things can happen. So oxidation state of nitrogen here is -3. That is the correct answer. Very good. So basically, all these amino acids, they have primary amine, right? So you have N with 2 hydrogens connected to a carbon with 2 hydrogen again, and then it is connected to another carbon with COOH group. Okay, so if you look at this nitrogen only, so it is connected by 3 single bonds, right? And all these molecules that are attached to these to this nitrogen, they will give a plus charge. So nitrogen is electronegative here. Okay, it is more electronegative than hydrogen, it is more electronegative than carbon. So it will withdraw electron from all these 3 atoms, and the single bond, so it will electron 1 it will withdraw 1 electron from these atoms. So it will have total net -3 oxidation state. So this is +1 and this will be -1. Then again this will be +1, this will be -1. Then this will be +1, this will be -1. So total -1, -2, -3. Okay, so total oxidation state will be -3. That is option C. This is clear? Hope that's clear to everybody, right? So the nitrogen in lysine will have the oxidation state of -3. Moving on to the next question. Anybody has any doubt till any of these questions discussed now? Anyone has any doubt in any of the questions discussed till now? Clear to everyone, right? We'll move to the next question then. Question number 10. Breakpoint chlorination of water involves the addition of sufficient amount of chlorine to option A, react with any ammonia and readily oxidizable matter present in water. Option B, kill the Giardia cysts present. Option C, react with ferrous ion only. And option D, reduce the growth of bacteria in filters. Breakpoint chlorination of water involves the addition of sufficient amount of chlorine to. Why do we add the chlorine to the water during this break, and what is the breakpoint chlorination? So breakpoint chlorination of water, it will involve the addition of sufficient amount of water, sufficient amount of chlorine to react with any ammonia and readily oxidizable matter present in water, or it is added to kill the Giardia cyst present, or it is added to react with ferrous ion only, or it is added to reduce the growth of bacteria in filters. Okay, Ipsmita says option D. Okay, anyone else? So we have two answers as option D, one answer as option A. Anybody else wants to answer? Is anyone answering, or should I show you the answer? So we have fight between option D and option A. So the correct answer is option A. So I told you chlorination is done. Whenever chlorination is done, it reacts with all the oxidizable matter. It reacts with ammonia present in the water. And breakpoint chlorination is basically the point where everything is now oxidized, and now the free chlorine is again detectable in the water. Okay, so basically whenever we add the chlorine, I told you about the chlorine demand, right? So whenever we add the chlorine, some amount of chlorine will be completely used to react with all the organic compounds, and then there will be some chlorine left. So initially what will happen when we add the chlorine, the residual chlorine, you will see no residual chlorine, because all the chlorine is busy reacting with the organic compounds. Once all the organic compounds and all the ammonia present in the water have been oxidized, then what will happen? Now whatever chlorine is remaining, they will start appearing in the water, and they will be detected as free chlorine that would be predominant in water. Initially those chlorine will be combined with these organic matters, so combined chlorine will be in predominance, and then later free chlorine will be in predominance. Okay, So you can see the reactions written here. So ammonia will react with chlorine to form the nitrogen and HCl, hydrochloric acid. Okay. Also, ammonia in presence of water, when reacts with chlorine, it will get converted into nitric acid and hydrochloric acid. And then different organic compounds, when react with chlorine, they will form trihalomethanes. I told you about trihalomethanes in the first question. So they will form these trihalomethanes. Okay. So I hope you understood what breakpoint is and what is happening with all these organic compounds and ammonia when coming in contact with chlorine during chlorination. So that's why breakpoint chlorination of water involves the addition of sufficient amount of chlorine to react with any ammonia and readily oxidizable matter present in water. Okay. It also reduces growth of bacteria, but it will reduce the growth of bacteria in water, right? Okay. I hope that's clear to everybody. The previous question is clear to everybody, right? Then I'll move on to the next question. Question number 11. THMs are produced in the drinking water during chlorination. The THMs are option A, acidic in nature, option B, alkaline in nature, option C, carcinogenic, and option D, complexing agents. So THMs, I told you what are THMs. THMs are trihalomethanes. Trihalomethanes. Basically, in methane, instead of the 3 hydrogen, there will be some halogen compound attached to it. Okay, so CHCl3 or CHBr3, these will be trihalomethanes. And these trihalomethanes, when produced in drinking water, they are actually, are they acidic in nature or alkaline in nature or carcinogenic or complexing agent? What are they? Anybody? If Smita is saying option B. Anyone else? THMs are, trihalomethanes are what? Are they acidic in nature or alkaline in nature or carcinogenic or complexing agent? Come on, others, you also answer. So THMs are carcinogenic in nature. Okay. So what do you mean by carcinogenic? So correct answer is option C, carcinogenic. What do you mean by carcinogenic? Carcinogenic means an agent can cause cancer. Okay. Any agent that can cause cancer is called carcinogenic. Okay. So THMs are highly carcinogenic, and that's why chlorination of water sometimes can lead to production of these THMs, trihalomethanes, and that can be harmful to us. Okay, drinking of water contaminated by trihalomethanes are going to be very dangerous for us because it can lead to cancer. Okay, so any agent that has a potential to cause cancer is called carcinogen. Okay, so THMs are carcinogenic in nature. I hope that's clear. All of you who are joining now, I hope you know that the class starts at 8, right? The class starts at 7. It doesn't start at 8. Because I have noticed in the previous classes also, a lot of people joins at 8 or around 8 suddenly. So I just want to make sure that everybody knows that the class starts from 7 p.m. and ends at 9 p.m. Okay. Anyway, moving on to the next question, question number 12. In iodometric titration using sodium thiosulfate as the titrant and starch as the indicator, the end point is determined through the appearance of. Whenever you are doing an iodometric titration using sodium thiosulfate as the titrant and the starch as the indicator, end point is determined through the appearance of option A, pink color, option B, blue color, option C, red color, option D, yellow color. Option A, pink color, option B, blue color, option C, red color, option D, yellow color. So what color do you see at the end point? How do you determine the end point in an iodometric titration where you are using starch as the indicator? So basically starch and iodine gives what color? So we have two answers, C and B. Anyone else? I see a lot of you have joined the class now. So I hope more people answers. And all of you who have joined the class now, again, I am telling you the class starts at 7 p.m. So please join it at 7 p.m. There's no point of joining it just for formality. Okay, we have two people saying option B, two people saying option C. Pradeep, why are you raising your hand? Do you have a question?
No, madam, no.
So the correct answer to this question is
Blue
option,
color, madam.
yes,
B.
yes, B, option B. That is the correct answer. So all of you have answered option B. You are right. So basically, what happens in an iodometric titration? Uh, so in this case, we are doing this titration to determine the total residual chlorine that is present in water after doing the chlorination. So chlorine is basically getting detected, and chlorine can react with the iodide ion to form free iodine, and these free iodine can react with starch to give the blue color. So iodine and starch has a very iconic relation. They give this blue black color, so it is widely used in many types of reactions. Okay, so these are the reactions that are given the chlorine or the hypochlorous acid or hypochlorite ion or other chloroamines are there. So all these compounds, they can react and they can form free iodine, and uh, the liberated iodine is then titrated against the standard sodium thiosulfate solution. So how is the titration done? Titration is basically done by so you have a reaction in a flask at the bottom, and then you can attach a burette containing a defined volume of the titrant. In this case, the titrant is sodium thiosulfate, and then drop by drop you keep adding the titrant to the flask, reaction flask, and that titrant will react with the uh, liberated iodine in this case, and it will form a product. That product will react with the indicator that we are adding. So in this case, we are adding the starch as the indicator, and that indicator will detect the product, and it will give a color. And as soon as you see the change in color, so initially everything will be colorless, and as soon as you see the appearance of the blue color, you have to stop. Basically, you have to close the burette and see the amount of titrant required to completely transform all the iodine in the solution. And that is how you can determine the amount of iodine, and from the amount of iodine you can determine the amount of chlorine that was present, because chlorine was reacting with the iodide ion to form the free iodine, and free iodine will react with the starch to give the blue color. And as soon as all the free iodine is uh, utilized by the sodium thiosulfate, so based on that you can determine the amount of iodine present, and from the amount of iodine you can determine the amount of chlorine present. So this is how a titration is done, and in this case starch is used as the indicator, which gives a blue color with iodine. Okay, I hope that's clear to everybody. Anybody has any doubt in this, or anybody has any doubt in how a titration is done? Okay. If there's no doubt, then I can move on to the next question. Question number 13. If the chlorine dose applied in a water sample is 1.5 mg per liter, and the chlorine demand of that water is 1.3 mg per liter, then the residual chlorine is. So I told you what chlorine demand is, right? I hope you remember what chlorine demand is. What is chlorine demand? Chlorine demand was basically the difference between the applied chlorine, that was the chlorine dose, and the residual chlorine. So you have the chlorine dose that is applied in the water sample as 1.5 mg per liter. Chlorine demand is 1.3 mg per liter. So what would be the residual chlorine here? Very simple. Quickly calculate and tell me what would be the residual chlorine here. Option A 0.2 mg per liter, option B 2 mg per liter, option C 20 mg per liter, and option D 0.02 mg per liter. You have chlorine demand as 1.3 mg per liter, applied chlorine as 1.5 mg per liter. You have to calculate for the residual chlorine. What would be the answer? Quickly calculate, everybody. I have one answer in the chat box, option A. What about others? Applied chlorine dose is 1.5 mg per liter and chlorine demand is 1.3 mg per liter. Only one person is able to solve this question. So what is chlorine demand? I told you chlorine demand is the amount of chlorine applied that reacts with all the organic impurities in the water, and then whatever is residual chlorine, so it's the difference between that. Now solve it. You have the chlorine demand, you have the applied chlorine. So chlorine demand here is 1.5 mg per liter. 1.3 mg per liter. What is the applied chlorine? Applied chlorine is 1.5 mg per liter, and residual is what we have to calculate. So residual will be equal to 1.5 minus 1.3, that is 0.2 mg per liter. Is this that difficult for you to solve? I hope everybody is able to solve this. If you guys have a doubt in understanding chlorine demand or in understanding any of the terms, ask. Clear to everybody? Okay. And I'm telling you again, all of you who are joining now, the class starts at 7 p.m. Because I've been noticing it since 5 classes that everybody starts joining around 8 p.m. I hope you all know that the class has been going on since 7 p.m. and it's a 2-hour class. So this is how the question is solved. We have the chlorine demand, we have the chlorine applied and chlorine residual chlorine. So we have to solve for the residual chlorine, which is coming 0.2 mg per liter. I think in the question it was mg per liter, right? Yeah. So these will be mg per liter, not ml. Okay. Moving on to the next question now, question number 14. You are titrating iodine with sodium thiosulfate. The molecular weight of sodium thiosulfate is M. What would be the equivalent weight of sodium thiosulfate? If the molecular weight of sodium thiosulfate is M, its equivalent weight is what? Option A, M by 2, option B, 2M, option C, M, and option D, M by 4. What would be the equivalent weight of sodium thiosulfate if the molecular weight of sodium thiosulfate is M? Option A, M by 2, option B, 2M, option C, M, and option D, M by 4. Anybody knows the answer or wants to answer? Please write it in the chat box. Okay, I have one answer, option C. Anyone else? Okay, we have one more answer, option A, that is m by 2. Okay. Okay, option A is now getting more votes. Anyone else? So to calculate the equivalent weight, you have to think of the reaction also. So I have shown you the reaction previously in that other question about this titration. Sodium thiosulfate reacts with the iodine to form the iodide ions, right? If you remember the number of electrons released per molecule of sodium thiosulfate ion, so that would be equivalent weight. That would be helpful to solve the equivalent weight. Okay. Okay. So two people have said option C, two have said option A. So let's see what's the correct answer. The correct answer is actually option C. C, right? Huh? C, that is M. So this is the reaction. So this is sodium thiosulfate. Like this is the thiosulfate ion. And thiosulfate ion, two molecules of thiosulfate ion are releasing two electrons. Okay, when it is reacting with iodine. So two electrons are involved. Okay, so these two electrons are then taken up by iodine to form the iodide ion. Okay, so two molecules of thiosulfate are involving two electrons. That means the equivalent number of thiosulfate would be 1. So that means per molecule, only one electron is involved per molecule of thiosulfate, right? If two electrons are there for two molecules of thiosulfate, that means one electron is there for one molecule of thiosulfate, right? That means the equivalent number of thiosulfate is 1. So whatever is the equivalent number, the equivalent weight will be molecular weight divided by the equivalent number. That is clear? So if the equivalent number is 2, the equivalent weight would be m by 2. If the equivalent number is 1, then the molecular weight will be m by 1. That is equivalent to the molecular weight itself. So equivalent weight is, in this case, is equal to molecular weight. So whoever answered option C, very good. That's the correct answer. Whoever answered option A, or who all of you who have not answered anything, I hope this is clear to you. If anybody has any doubt, please ask. Okay. Then I'll move on to the next question. Question number 15. You are performing the oxidation of ammonia or ammonium salts to produce nitrites or nitrates. This process is called what? Option A, disproportionation. Option B, denitrification. Option C, nitrification. And option D, decomposition. So I've already talked about this, so most people should be able to answer. So basically oxidation of ammonia or ammonium salts into nitrites or nitrates. Ammonia going to nitrates or nitrites. That process is called what? We discussed that the process is done by nitrosomonas, right? But what was the process called? Okay, I'm getting option C as the answer. What about others? Okay, so a lot of people have answered option C. So that is the correct answer. Nitrification is the process where ammonia and ammonium salts are oxidized to produce nitrite or nitrate. So the other options that are there, apart from nitrification, we have disproportionation, denitrification, and decomposition. So denitrification I had already explained. What is disproportionation and decomposition? Let's see that first. So disproportionation, by name itself, you can see something is getting disproportionate into two different products. Okay. So one thing is breaking down, getting distributed into two different parts, and they are getting disproportionated. Okay. So this term is given in terms of the oxidation number. Okay. So here we'll have a compound where the nitrogen will have a certain oxidation number, oxidation state, and the products, if you look at the products, both the products will have a different oxidation state than what is there in the reactant. Okay. So in terms of nitrogen, this is an example of disproportionation reaction. So you have the NO2, that is nitric dioxide. NO2 reacts with water to form nitric acid and nitrous acid. Okay. NO2 reacts with water to form HNO3 and HNO2. Now you look at the oxidation state of NO2. How do you calculate the oxidation state of NO2? So overall charge on NO2 is 0, right? There's no charge on NO2. Nitric dioxide, it doesn't have any charge. Just a second. Just give me a second. I'm unable to open my screen here. I'll just reshare the screen. Just give me 1 second, okay? There's some problem with the PowerPoint. So by that time, if anyone of you have any doubt in any of the question, please ask me. I can clarify by the time I'm opening the PowerPoint. Okay. I hope the screen is visible. If one of you can respond. The screen is visible to everyone, right? Yeah. Okay. Thanks. Uh, so I was talking about disproportionation reaction, right? So here you see nitrogen dioxide. The nitrogen has the oxidation state of +4. How do we know that? Because so the overall charge on nitrogen dioxide is 0, right? So if I have to calculate the oxidation state of nitrogen in nitrogen dioxide, I will look at the oxygen that is bound to the nitrogen here. So there are two oxygen molecules, right? And oxidation state of oxygen is -2. So if there are two oxygen, then -2 into 2, that would be -4. And overall charge is 0. So if I consider the oxidation state of nitrogen here as X, it would be X -4 is equal to 0. So X -4 is equal to 0. So X will be equal to +4, right? So that is how we are getting the oxidation state of nitrogen here as +4. Similarly, if I ask you to calculate the oxidation state of nitrogen in nitric acid, so nitric acid, that is HNO3. So if you see with the nitrogen, we have 3 oxygens and 1 hydrogen, right? So hydrogen has an oxidation state of +1, oxygen has an oxidation state of -2. And if I consider N as the oxidation state of N as X, we'll have the overall oxidation, the overall charge on the compound is 0. So it will be +1 plus X and plus -2 into 3, right? Because 3 oxygen are there and each of them has -2 oxidation state, and this will be equal to 0. So this will be -6 plus 1 will be -5. So X -5 is equal to 0. So X is equal to 5. So that is how this nitrogen on nitric acid has a +5 oxidation state, but the nitrogen on nitrogen dioxide has a +4 oxidation state. And now we'll look at the nitrogen and nitrous acid, that is HNO2. So HNO2, that means this will become 2, this 3 will become 2, so this will be -4 plus 1 -3. So x minus 3 is equal to 0, so x is equal to +3. So the nitrogen and the nitrous acid is +3. So what is happening in disproportionation reaction is one compound having a particular oxidation state, it produces two different compounds with two different oxidation states. Okay, so nitrogen can exist in multiple oxidation state. Okay, if you remember from the one of the previous questions, we had discussed the oxidation state of nitrogen in glycine, and you remember the oxidation state of nitrogen in glycine was -3. Okay, and here in all these compounds you can see the oxidation state of nitrogen is +4, +5 and +3. So you can see nitrogen can exist in multiple oxidation states, and basically in disproportionation reaction, this is what happens. One oxidation state, from one oxidation state, two different oxidation states are produced. Okay, so this is disproportionation reaction. Disproportionation of oxidation number is happening. Now coming to the next reaction, that was decomposition reaction. So by name itself, you can understand what decomposition is. Decomposition means breakdown. Okay, in very simple language, decomposition means breakdown. Okay, so here nitrogen dioxide, NO2, is getting broken down into NO, nitric oxide, and oxygen. Okay, nitrogen dioxide is breaking down into nitric oxide and oxygen, NO plus O2. So this is decomposition. Another example of decomposition reaction where breakdown is happening is nitric acid breakdown. So nitric acid will break down into NO2 plus O2 plus H2O. Okay, so all these components will break down into its own inorganic simplest form. So nitric acid will break down into nitrogen dioxide plus oxygen plus water molecules. Okay, so this is called decomposition reaction where the breakdown is happening. Disproportionation, there disproportionation of oxidation states are happening. Then coming to denitrification, I told you denitrification is exactly opposite of nitrification. In nitrification, ammonia is getting oxidized into nitrites and nitrates. And in denitrification, nitrates are and nitrites are getting reduced to nitrogen. Okay, why I'm saying reduced? If you see the oxidation, now if I ask you to calculate the oxidation state of nitrogen and nitrate, so this is, and if you see in nitrate, we have a charge -1. So if I consider nitrogen, oxidation state of nitrogen as X, and this will be plus -2 into 3. And now this will not be equal to 0, but it will be equal to -1. So X is equal to, this will be -6 and it will go here. So 6 minus 1, X will be equal to 5. Okay, so the oxidation state of nitrogen in nitrate is +5. The oxidation state of nitrogen in nitrite would be +3. This will be -4. So 4 minus 1 would be 3. The oxidation state of nitrogen and nitric oxide will be +2 because this is -2. So this will be +2. Then here the oxidation state will be, so then now we have 2 nitrogen. So this will be 2x -2 is equal to 0. So x will be equal to 1. So this will be +1. And here the nitrogen will have an oxidation state of 0. So you can see a reduction is happening. From +5, we are going to +3. From +3, we are going to +2. From +2, we are going to +1, and then we are reducing it to 0 oxidation state. So this is the denitrification process, which is a reduction process. Okay, reduction is happening. And in nitrification, oxidation is happening. How oxidation is happening? So in ammonia, you can see the oxidation state of nitrogen is -3, and it is getting converted into nitrite, that is +3, and nitrite is getting converted into nitrate, that is +5. So from -3, it is getting increasing. It is increasing to +3 and +5. So that means it is getting oxidized. So this is oxidation process. Oxidative process. Nitrification is oxidative process, whereas denitrification is a reductive process. Okay, so this is how a nitrogen cycle keeps on going on. So you will have ammonia, you will have nitrogen that will get fixed into ammonia. Ammonia will get converted into nitrites and nitrates. First nitrite, then comes nitrates, and then nitrates will again go back to nitrogen by the process called denitrification. Okay, here you can see nitrates are going back to nitrogen as denitrification. Nitrogen will get fixed into ammonia by nitrogen fixing bacteria. I gave you an example called rhizobium. Okay, ammonia will get oxidized by the process of nitrification. Ammonia will get oxidized by the bacteria called nitrosomonas. Okay, so you should remember the bacteria also. You should remember the processes also. Okay, this is the nitrogen cycle. I hope all the reactions are clear to everybody. Great. I'll move on to the next question now. Question number 16. In an experiment, a concentration of 0.1 gram per meter cube of free available chlorine affects 99% kill of bacteria in 8 minutes. Okay, a concentration of 0.1 gram per meter cube of free available chlorine affects 99% kill of bacteria in 8 minutes. So it is killing 99% of bacteria in 8 minutes. Calculate the disinfection rate constant. Okay, you have to calculate the disinfection rate constant. Now in this question, I'll tell you the formula that you have to use, and I'll request all of you to do the calculation on your own. So the formula that you will use is Nt is equal to N0 e raised to the power of minus k C T. So basically here Nt is the final number of bacteria in this case. N0 is the initial number of bacteria. E, I have told you the value of E is around 2.7. It's you can use your calculators to solve for E as well. K is the rate constant that we have to calculate. So K is the rate constant. This is what we have to calculate. C is obviously the concentration. So concentration is given as 0.1. You can use the same unit. And T is time. Okay, T is time. So time is given as 8 minutes, and in answer also we have the solutions in minutes. So you don't have to convert any of the units. You just have to think of the final and the initial number of bacteria. So you have the percentage of bacteria. So in 8 minutes, that is time, 99% of bacteria are getting killed. That means if initial number of bacteria is 100, then final number of bacteria would be Final number of bacteria would be, if initial number of bacteria was 100 and I'm saying 99% of bacteria is getting killed in 8 minutes, then what would be the final number of bacteria? The final number of bacteria would be 1, right? Because from 100 bacteria, 99% got killed, so remaining is 1. One bacterium is remaining. So final number would be 1, NT will be 1, N0 will be 100, K you have to calculate, C is 0.1 given in the question, T is 8. So I've told you everything. Now just put the values in the formula and solve. Use your calculators to solve this. You will get the digital calculator in the exam also, so you should know how to use a calculator to solve for logarithmic equations, because if you don't know how to use a calculator, giving you a calculator is also not going to help you solve a question, right? So you should know how to solve for these questions. You know, in all the scientific calculators, e to the power x is there. So use that, solve for k. If I have to take the whole term on the other side of the equation, what do I have to do? If I have to take the uh, power that is there, that is minus k, c and t, if I have to take it to the left hand side of the equation, that means the e to the power minus kct will become natural log of kct on the left hand side of the equation. So use those information and solve the question. I have 3 answers here, option C and option A. Did you guys calculate it, or you are just guessing it? Now I've told you what values to put. So calculate it again. Okay, Deepika is getting option B. What about others? Tejasvi, Dharmika, you have answered option C. Okay, I'm getting more and more option B now. Kiran has answered option B. What about people who have answered option C and option A? Are you actually getting those answers? The correct answer is option B. So let's see, let's look at the solution. So I told you NT is the final number of bacterium. So if 99%, just a second. So if 99% of bacteria are getting killed in 8 minutes, that means out of 100, 99 got killed. So how many is remaining? 1 is remaining, right? So if I consider the initial number as 100, so final number will be 1. So 1 by 100 is equal to e raised to the power of minus K into 0.1 into 8. Till this point, it should be clear to everybody. Now to solve this, 1 by 100 would be 0.01. This is equal to e raised to the power of minus kct. So that means minus kct will be equal to natural log of 0.01. If you solve this, you will get something in negative. So negative sign will get cancel the negative sign, and just divide this. To solve for k, just divide log of 0.01 by minus ct. So when you solve the whole thing, so c is 0.1, t is 8. So that means this is 0.8. So this will be ln 0.01 divided by minus 0.8. So when you solve this, you will get the answer as 5.756. Okay, and the unit will be minute inverse. This is clear to everybody? So all of you who have not answered option B, is this clear to you? Great. Okay, then I think I can move on to the next question. Anybody has any doubt in this question? Anybody has any doubt in calculation? Please ask. Everybody understood how to do the calculation? Everybody understood how to solve this question? Okay, if it is clear, then I can move on to the next question. Question number 17. Which of the following is the correct order of disinfectants arranged according to their increasing order of disinfection power? Which of the following is the correct order of disinfectants arranged according to their increasing order of disinfection power? Option A, ozone, then HOCl, that is hypochlorous acid, then monochloramines, and then comes this is NCl3. So this is trichloroamine. Okay. Option B is ozone, then trichloroamine, then monochloramine, and then HOCl, hypochlorous acid. Option C, NCl3, HOCl, monochloramines, and then ozone. And option D is NCl3, monochloramines, HOCl, and ozone. So which has the highest disinfectant power and which has the lowest disinfectant power? So what do you think the answer will be? Okay. Option C, option D, 3, option D, then option B. Okay, various answers are there. What about others? Come on, answer. Option C. So I have all types of answers. So the correct answer is option D. So most of you who have answered, the maximum vote went to option D. So that is the correct answer. Does anyone have any question? I see raised hands here, so that's why I'm asking. So option D is the correct answer. So the ozone has the maximum disinfectant power. So ozone is the highest highest level of disinfection you can achieve with ozone. Then comes the hypochlorous acid. I have already told you hypochlorous acid is the main disinfectant agent present in all these bleaching powder and all. then comes the monochloramine, and then comes the trichloramine. So as you decrease the chlorine in the decreasing order of the halogen in the amines, you will have the increasing disinfection power. So NCl3, then monochloramines, then HOCl, and then ozone. So that is the correct order, increasing order of disinfection power. That's clear to everyone? Moving on to the next question. Question number 18. A rural water supply scheme serves a population of 10,000 at the rate of 50 liter per capita per day. For the chlorine dose of 2 ppm, what will be the required amount of bleaching powder with 20% available chlorine? Now in this question, it is already given that the bleaching powder has 20% available chlorine. Okay. So if I have a population of 10,000 and the rate of 50 liter per capita per day. Okay, water supply, rural water supply scheme serves a population of 10,000 at the rate of 50 liter per capita per day. Then what would, and the chlorine dose is given as 2 ppm. Then what would be the amount of bleaching powder that is required to do the chlorination of water if the available chlorine is 20%. So first you have to find the amount of chlorine required, and then we'll find the amount of bleaching powder required. Okay. First we'll have to find the amount of chlorine required. So chlorine dose is 2 ppm. So what would be the amount of chlorine required for the whole population, for the whole area? After calculating the amount of chlorine, we can calculate the amount of bleaching powder, considering that only 20% is there. So amount of bleaching powder required would be higher than the amount of chlorine, obviously. If anybody knows how to solve this? Anybody is able to solve this? Write the answer in the chat box, otherwise we'll discuss the solution. Okay, let's discuss the solution. So the population is 10,000, right? And the supply is 50 liter per capita per day. So the total supply would be 50 into 10,000 liter per day. So in one day, 50 into 10 raised to the power of 4 liters of water is the supply, right? Yeah, I see raised hands. Do you have any question? Abhi Gumma and Kilari Ganesh, do you have any questions? Okay, I'm lowering your hands then. So we have the population as 10,000. So supply would be 50 liter per capita per day. So total supply would be 50 into 10 raised to the power of 4 liters per day. Or we can write as 5 into 10 raised to the power of 2 meter cube per day. 1 liter is equal to, sorry, 1 meter cube is equal to 1000 liters. Okay. So 1000 liters is equivalent to 1 meter cube. So this will be 5 into 10 raised to the power of 2 meter cube per day. That is the total water supply. Now chlorine dose is 2 ppm and 1 ppm is equal to 10 raised to the power of minus 3 kg per meter cube. Okay, or 1 kg per meter cube is equal to 1000 ppm. So 2 ppm chlorine dose will be equivalent to 2 into 10 raised to the power of minus 3 kg per meter cube. Now, amount of chlorine required per day would be 2 into 10 raised to the power minus 3, that is the dose, multiplied by the total supply. Okay, that would be the amount of chlorine required per day, because chlorine dose is basically defined as how much chlorine is required per meter cube or per unit area. Okay, and now you or per unit volume, not area, per unit volume. Okay, and now you have the total volume of water required in 1 day. So what would be the amount of chlorine required in 1 day? That would be chlorine dose multiplied by the total amount of water. So that it comes around 1 kg, right? So 1 kg of chlorine is required. Now in bleaching powder only 20% of chlorine is available. So if I require 1 kg of chlorine, so let's say I will require X kgs of bleach or X kgs of bleaching powder. So 20% of X would be equal to 1 kg, right? 20% of X should be equal to 1 kg. So X will be 1 into 100 by 20. That is what we have done here. So this will be equal to 5. So when you take 5 kgs of bleaching powder, then because there is only 20% of chlorine is there in bleaching powder. So 5 kg of bleaching powder will have 1 kg of chlorine, and 1 kg of chlorine is required per day to do the chlorination of the total supply of water that is present in a particular area, that is supplied in a particular area. This question is clear to everybody? If anyone has any doubt, please ask. Everybody understood the solution? Do you have any doubt? So I'm getting no response. So either you have all understood or either none of you have understood anything. So at least someone respond and tell me if there's any doubt. Okay, great. Okay, the next question is question number 19. What is the remaining percentage of pathogen after 1 minute of contact time during chlorination? Assume K to be 0.046 per minute. So we have to calculate the remaining percentage of pathogen after 1 minute of contact time during chlorination. So this will utilize the same formula. So NT will be equal to N0 e raised to the power of minus KT. So K is given as 0.046 and we have to find out the remaining percentage. So we have to basically calculate the NT. So let's consider N0 as 100 because we have to calculate it in percentage. E raised to the power of minus 0.046 into 1. Time is 1. So now you can easily calculate this. What is the answer to e raised to the power of minus 0.046? 0.046 with a negative sign and power of e. This will come around 95.5. Okay. So 0.955 would be the answer. So 100 into 0.955 55, and if you further solve it, then you will get 95.5%. So the correct answer is option B. Okay, this is the same formula that we have used previously. So the remaining percentage of pathogens after 1 minute of contact time during chlorination, where K is given as 0.046 per minute, is 95.5%. This is clear to everybody? Okay, that brings me to the last question of this session. Which of the following statement is correct? Pre-chlorination minimizes the formation of THMs. Substances used for disinfection of water is known as coagulant. Chloramines are known as free chlorine residuals, and all of the above. Which of the following statement is correct? Pre-chlorination minimizes the formation of THMs. Substances used for disinfection of water is known as coagulant. Chloramines are known as free chlorine residues, and all of the above. Which statement do you think is correct? Ipsnita says option A. Anyone else? So you're right. Option A is the correct answer. Pre-chlorination minimizes the formation of THMs. I told you THMs are trihalomethanes. They are carcinogenic. So it's better to do pre-chlorination because it is minimizing the formation of THMs, which are harmful for us. Substances used for disinfection of water is known as disinfectant. Chloramines are not the free chlorine residues. Chloramines are compounds. They are basically amines, basically ammonia with the hydrogen replaced with the chlorine atoms. Okay, so those are chloramines. So monochloramine will have one chlorine, trichloramine will have three chlorine, like that. Okay, so this is the last question of the session. I hope everything is clear. Whoever has any doubt, let me know. So anyone has any doubt? Anybody wants me to repeat any of the questions? I can go through it again. If you have any kind of doubt in any other topic in this session, let me know. Okay, great. If there's no doubt, then we can end this session. Thank you all for joining, and we'll meet whenever we'll have the next session. Okay. Thank you. Bye bye.